This session is about the logarithmic differentiation. Sometimes we do have a function that involves a product, quotient, power, which looks complicated. In order to simplify a function, in order to find the derivative in the easier way, we have to take a logarithm of both sides of these functions. And this method is called logarithmic differentiation. That means taking a natural log of both sides of the equation, y equals to f of x, and use the laws of logarithm to simplify, will be the first step of the logarithmic differentiation. Then we will differentiate using the implicit differentiation with respect to x, and the final form we will solve for y prime, and this will be our answer. So let's see how we can apply a logarithmic differentiation. Let's look at these four functions. So when we have a function, let's maybe clarify a and b is a constant. Okay, a is constant, b is constant. And then f of x, g of x are the functions that we can get the derivative, differentiable function. Okay, the first formula that I type for you is just a to the b. Looks like a power form or exponential form, but however, it's just a constant. Like, for example, 2 to the power of 3, constant. Derivative of the constant is 0. Okay, now the second line shows us the power function, x to the power of b, or f of x to the power of b, when we will apply the chain rule. It means derivative of f of x to the power of b is b, f of x to the power of b minus 1, and follow the chain rule times derivative of f of x. Now, the third line represents the exponential function, derivative of the exponential function, because x is placed in the exponent, a to the power of g of x. Derivative of this is the same function, a to the power of g of x, times natural log of a, the base, and follow the chain rule, derivative of g, derivative of the exponent, g prime. The last one, the fourth line, looks a little bit different because we have a function, I can maybe write underneath, f of x taken to the power of g of x. And we're looking for the derivative of that form. So first of all, please note it's not really an exponential function, it's not really a power function, because power function doesn't have x in the exponent. Exponential function doesn't have x in the base. That means this is function taken to the power of another function. In order to find the derivative, we will use a logarithmic differentiation. Exercise number 1. Differentiate x to the power of root x. Taking the logarithm of both sides, ln of y, ln of x to the root x. Now, having this as an exponent, we may put this in front of the logarithm. And this move create a product, and I can use the product rule because now I will differentiate both sides. Derivative of natural log of y is 1 over y times y prime. Now, product rule on the right-hand side. Derivative of root x is 1 over 2 root x times ln of x plus root x times derivative of ln of x is 1 over x. Okay, let's multiply both sides times y because we have to isolate y prime on the left-hand side. That's what we're looking for. We're looking for y prime, derivative of the original function. Okay, one thing that we may do, instead of y, I can substitute back the original function, x root x. And we may get a common denominator in this bracket, just to simplify. Having a common denominator, we will multiply. Oh, actually, I did simplify first. Square root of x over x is x to the power of 1/2 over x to the power of 1. When we dividing the same base, we can subtract the exponent. 1/2 minus 1 is -1/2, and this is square root of x in the denominator. Okay, and now the only thing that is missing for the second fraction is 2 in order to see the common denominator. So we can multiply by 2, and that's the final answer. But the main message on this is the logarithmic differentiation. Let's look at the second exercise. However, I do have this exercise solved using a little bit different method. I can take this function and actually rewrite as an exponential function. Okay? Which we remember that if we do have e to the power of ln of a, it is a, because it's the cancellation equation. I mean, this is my a. Okay? E to the power of ln of my quantity a. Okay, I can't erase this. And now, having two exponents, I can multiply them, and I will apply only the differentiation of the natural exponential function. I'm just saying about this. Okay, I mean, we have a function e to the power of square root of x ln of x. Derivative of this is the same function, okay, times the derivative of the exponent. Follow the chain rule. And derivative of the exponent looks like this, which we actually did on the previous slide. And I can get a common denominator, and this form I can rewrite back as the original one. That means you may pause the video and compare to the first slide the logarithmic differentiation method. And that means I just want to show you that we do have another method. Okay, but I have another two exercises, and I will only use the logarithmic differentiation. Exercise number 2. Tangent of x to the power of 1 over x. Okay, as we can see, function to the power of another function. Okay, I took ln of both sides, natural log of y, natural log of the right-hand side. The exponent 1 over x is placed in front of the logarithm. And now let's differentiate. Derivative of ln of y, it's 1 over y times y prime. Derivative of 1 over x is -1 over x squared. You may use the power rule on the side. Times the second function plus 1 over x times derivative of ln of tangent. It's 1 over tangent of x times derivative of tangent, which is secant square of x. Okay, almost done. Multiplying both sides by y, we isolating y prime because we're looking for y prime. And another thing, we may rewrite y as the original formula, tangent of x to the power of 1 over x. And what we have, this quantity in the brackets, this quantity is negative, then I placed as a second one. This quantity is positive, I placed here. Secant square of x over tan x and x, and I copy this. And we may try to get a little bit different form, but I believe this form looks good for the final answer. Secant square is 1 over cosine square. Tangent is sine over cosine. That means simplifying this, I got cosecant of x times secant x. Okay, I can possibly do this for you. Secant square, actually, it's 1 over cosine square. I can rewrite like that. And tangent is sine of x over cosine of x. You can cancel this. 1 over cosine and 1 over sine is cosecant times secant. 1 over cosine, let's say 1 over sine first, cosecant times secant of x. Just to know where these formulas come from. But But as I said, this could be also your final answer. And 1 over x and 1 over that x is a common factor. I factor out. Okay, let's look at one more. X to the power of sine of x. Finding the derivative, we will use the logarithmic differentiation, taking ln of both sides, putting sine of x in front of the logarithm, and let's differentiate. Derivative of ln of y, it's 1 over y times y prime. On the right-hand side, product rule. Derivative of sine of x is cosine of x times ln of x. Plus, we will copy sine of x, and derivative of ln of x is 1 over x. Done. Multiplying both sides by y, and rewriting y as the original function. I mean, the bracket in the parentheses, we don't have to do. We may try to get a common denominator, but we may leave it like that. Okay, thank you.